So you've come to, apparently, I'm not quite sure why you're here and not listening about how to use LLMs. You've come for a talk with this wonderful title. Maybe it's the AI bit that got you, because there are 3 talks on at the moment which got AI in them, so maybe that's it. Right. We're going to take this apart in a second. So first off, though, my name is Steve Poole. I work for a company called Sonatype, who are in the secure software supply chain business. We run Maven Central. I've been a JVM developer, and I've done other things. And one of the things that I did, which is relevant to this talk, is I used to run IBM's European DevOps team. And that taught me a lot of how you get teams to communicate. And that experience is going to be reflected in the back half of this conversation. Right, so I work for Sonatype, which you may or may not hear and know about. We do software, supply chain security. So it's dependency management, vulnerability scanning, all those sort of things. And whether or not you use us, whether or not you use somebody else's, it is an important aspect of moving forward. So let's start to break this down. So let's start with a reality check. All right. So these words, which I put in the title, are a bit, well, too much, aren't they? But if we were to change them slightly, you might get a better understanding of what this talk is about. Right. So, bad things are happening in software. Added to that is there's lots of fears about AI, and that is leading to a lot more thoughts about legislation and just control. Right? And that, unfortunately, equals more work for developers and DevOps and AppSec. I mean, everybody involved in shipping software, etc., is going to have to work better. And if we screw it up, it means more hacks, more ransomware attacks, more fines for your company, and possibly prison. I'm going to go through some of those pieces. So let's start with the bad things. What's going on? Well, I could give you all sorts of detail, but I'm going to give you one slide and then a couple of other bits and pieces. But what you have to understand, and this will explain why this is a problem that is becoming a world problem, is the amount of money that the bad guys steal from us, or the amount of money they cost us, because when they do bad things like ransomware attacks, they may take money off you, but the consequences of you paying them it's a bigger problem. So there is this mix of the amount of money they make, steal, versus the cost to you to recover, right? And it's at $9 trillion. So that means, as you can see, if we measured it as a GDP of a country, it would be the 3rd largest country in the world. So you see why this is a big problem. You can see why legislation and laws are heading our way, because this is out of control. And this is just the money aspect. Connected to this challenge is a lot of what I would call nation-state activity, cyber warfare. Because the tools that are used to steal money are also the tools that can be used to compromise other people's systems. And so each government understands the cost and the benefit, but they still need to see it controlled, right? And one of the ways, from our point of view, that these bad guys get in is via open source. What you call an open source attack, when you look at the different ways that what attacks are happening, you can see what the vectors are. And those that are targeting the open source projects that we consume, the things we download, have dramatically risen. Okay, it's just going through the roof, because it's a way in. And recently you would have heard about this XZ thing. You may have heard about it, but basically it was a vulnerability that was used to get past SSH security. The backstory to this is that there was a thing called a benevolent stranger attack. And this is where the person who is the committer on this X-Edge project has expressed interest in maybe somebody else helping. He wants to move on to other things. And people turn up and start to poke at him because what they want to do is to get him to give up complete ownership. It's what's called a benevolent stranger attack. It's also used what are called sock puppets. Sock puppets are what you may think of being lots of people, but they could easily be one person just having multiple accounts. The objective, and in this case it worked, is to get these guys, the committer to give up, move away, and then they make use of it, they look after it for a bit, and then they start putting in backdoors and changes and stuff like that. Okay, this is not common, but this is happening a lot. Right? There are lots of ways to get there. One thing you have to understand is that only 11% of this open source that we use has a maintainer. So much of the open source that we use is just sitting there not being used, not maintained. So it's not a great situation. And to add to it, you as consumers of this stuff aren't paying attention either. Because when you download something from the internet, you're looking for a solution for something, you pay very little attention to picking a quality component. You go to Google, Stack Overflow, you put some words in, you get something, you put it into your dependency pack, whatever it is, whether it's Java or Python or whatever, you select something. 96% of the time that you do that, there is a better, safer version available if you've just done the research. Okay? This is not good, right? These are nice, wonderful data. And if you're a Java developer, you'll have heard about, presumably a few of you may have spent a Christmas or two looking after Log4Shell, right? This is still active. Look at the numbers. So we, Sonatype, keep track of the things that get downloaded. We look at, there's all sorts of patterns we collect. The takeaway from this is that today, in the last 7 days, 35% of the downloads for log4j from Maven Central were for vulnerable versions, ones with the Log4Shell vulnerability in. 35% of them. Right? Goes up and down, but it's in that bucket. Right? And as you can see from the data underneath, the NSA published a list of the top vulnerabilities being exploited by China, and what's number one? Apache Log4j. This, Log4Shell, was used as almost like the final straw. A lot of governments, especially the US government, saw this and said, it's a real demonstration that software industry cannot regulate itself. Because even with something as obvious as this, as bad as this, we still have people using it. So we have to do something about it. Okay? So you can see there's the first set of problems that we have, in that governments look at us and go, there is a big problem, and hey, Mr. Software, consumers, Mr. Software producers, you've got to fix it. And then, of course, AI turned up. Right, that's cool. Let's see how about this?
It's like a slap in the face, that's all I need.
Like this?
Take a swing. Everybody swings. Okay.
Yeah. Feels really good.
This is easy to do. None of these are Tom Cruise. But it's hard to tell. You look at this guy in the middle.
Guys, I think I see Tom Cruise.
He's so he just wants fame, doesn't he? This is easy to do. What happens is there's an actor who's very similar in build, and he does some of these things, and then they've put the face over the top. There's a whole TikTok channel, Deep Tom Cruise, right? This stuff is easy to do. And the reason I'm putting this here is because it is now part of mainstream attacks. We have so many situations where fake people are being used. So now we're moving from the old kind of phishing things, now we're getting email, now we're getting fake Zoom calls. You could be on a Zoom call and everybody else on that call could be fake. And that's already happened. We have insight of that. So you can see the governments are going, this is bad too. Right? The thing is, there's loads of ways. If you've ever been to Hugging Face, there are loads of models out there. There are loads of stuff you can go use. There's just tons of stuff. Go pull this stuff down. Most of this, we hope, is legitimate. But lots of these models have no provenance. And models themselves are dangerous, and I'll explain in a second. But the explosion of use of AI has been another great thing for the bad guys. But you can imagine governments are somewhat concerned. And even the models, I say the models are dangerous. They're simple. There are simple things like, as a Java developer, if you go to Hugging Face and want to play with some of this, it may require you to install Python. And as a Java developer, you may not think that's a bad problem. But Python is, like Node, has an enormous amount of malware in the package on the online repos. And if you don't realize what you're getting into, suddenly you download Python. You can install malware on your laptop just by running one of these things, courtesy of trying to get a model to work. So our attitude to this stuff gets people very concerned. The models themselves can get what's called poisoned. So models themselves can be trained so that they behave nicely. So imagine you go to Hugging Face, you want a ChatGPT equivalent. You go to Hugging Face, you download what looks like a great model. It's been pre-trained, gives you some great advice on what you can do with it. You download it. You put it into training mode because you want to teach it about your data. That'll be on the left-hand side. And at some point, you put it in production. At which point, the model flips behavior and becomes evil. And it's quite straightforward to do. You can just do it like date-based. So I can train a model that says, behave nicely until it's 2024 or 2025. And then somebody downloads it, put it in production, bad things happen. Bad thing happen could be anything, right? It could be a Copilot thing generating insecure code. It could be a backdoor thing where you could come up with a particular strange prompt request and it will give you access to the other systems. It could do anything. It is indetectable because whether this is good or bad depends on your point of view. So currently, there is no way to check whether something is poisoned. Okay? And then even if they're not malicious, they're still a problem for all of us because if you use them incorrectly, and you may have heard about the Air Canada one, where basically the Air Canada had a chatbot, made a deal with the customer, Air Canada went, we're not honouring it, got taken to court because from a legal point of view, it was representing your company. The fact that it went off and did something stupid is irrelevant. Not the customer's fault, your fault. So you have that. And then they're very hard to scope these things. So the other one is an example of an Amazon chatbot, which rather than going, please help me about an Amazon product, somebody typed in, create a reverse shell in Python. And it did it. Because when you use these very well-trained, very extensively trained AI, they do all the things they do. And trying to prevent it doing that in your certain circumstances becomes difficult. So you can see why people get concerned, right? So from one point of view, everybody's really, really worried about AI. right? And not this, is it going to become the singularity, which obviously this guy would like to achieve, but it is the whole race to include this and using technology that's very powerful, but has very sharp edges. Right? So we're trying to figure out how we're going to fix that. So now we can talk about the boring bits. Okay? Legislation control. Lots of companies. There's a bit of it out there. If you go digging, and I've just bought, these are the top ones. There are a few more out there. But you can see the Act. Some countries are producing particular acts. They're in the process. Some of them are already law. Others are just looking at the laws that they've had before and figuring out how to reuse them. But you can look at some of the consequences of breaking these rules. Mostly it's money, but occasionally it'll be imprisonment, right? If you want to get your head around it, what you have to understand is that governments do not understand about software. So they have to have another model. And the model that comes up the most often is automotive industry, creation of cars, right? Industry, creation of things. So they look at it like that. And if, for instance, you shipped a car and the airbags didn't work and you knew, somebody would be criminally liable. You'd have to have a recall process. You know, you have all these things that you're required on, but the consequences of doing it wrong and knowingly doing it wrong can be quite draconian. And you can see all these things. I mean, this is a big, big stick. I mean, probably the least big stick is the one for the US government, but it has the same consequences, which is like, you can't do business with us unless you do the right things. Others just going, you did the wrong things, we're going to find you a big chunk of money, and then we may take you to court, and then you might go to prison. Right? That's software supply chain things. That's dependencies and dealing with security. And then there's a bunch of AI ones as well. Right? Even the UN is bringing people together. They want to fix this problem. Look, even China, who benefits from this dramatically, the situation, looks at having some sort of control systems, because much as these things are great weapons, you still have to have defenses. And so you want to be able to defend against these. You know, it's everybody's looking at this from that point of view. Right? And there's a lot. Right? So they're all beginning to wake up. I mean, this is not, this has been going on for 2 or 3 years. I've been in a few of meetings that have government representatives there in the US. And there are lots of people. Linux Foundation, others are involved. Sonotype participates, others. And we're trying to figure out what the right answers are, because nobody wants to get in the way of stopping innovation and stopping open source happening. But on the other hand, we have to fix these problems. And when you start trying to sum it up, there are all sorts of things that impact every part of the software supply chain, every part of how we do development. Right? I tried to put together a picture, and it starts to get just too messy. But if you look at each of the steps, every one of these yellow things is somebody somewhere says you will do something, right? And you can see, however it comes in, whether it's your source code coming in, whether it's the infrastructure, whether you're using third-party infrastructure, somebody has a view that what you use to produce your software should have some element of regulation. Not necessarily big R, but people are going, we should do these things. Right? Lots of proof, right? So I tried to sum it up as to the sort of things that you are going to get asked to do. So the first one is that everybody says is an S-bomb. Anybody heard of S-bombs? A few of you? Yeah, okay. So there's an AI equivalent called an ML bomb. But honestly, it's a bill of materials of what's in the thing I'm giving you. So that's like a common one. And then the other thing is, you look at the words, evidence, audit, demonstrate. People want you to demonstrate that you have a robust system that delivers the software, whatever you're delivering, and that you can prove it wasn't tampered with, and that you can prove that you did the right thing. That things like does not ship with known severe vulnerabilities, the airbag thing, prove that you ship and it's safe, right? Have a recall update process. There are some governments that are looking at going, well, if I give you a piece of software, if you ship software, you should have the ability to ship an update. And in fact, they're looking to the point of going, we want you to be able to force an update on customers, right? Because that may be the safest way to do it. So you can see we're going away from the laissez-faire approach we had to software development to it becoming much more regulated. So there we are. This is sort of halfway through. So what do we got? We have this situation with cybercrime where we have the bad guys trying to use our systems, trying to compromise our systems, steal money. We have nation states who want to fix it, but also want to be able to still do those things because it's such value, so they've had that problem with it. Things like zero-day exploits. So that's an exploit, vulnerability that gets published, and there's a patch immediately, but it's like now, right? It's being exploited now. We tell you about it's being exploited now. Those are much more common than ever, and in fact, to be honest, there's a lot of things that are not zero-day. They're already being exploited by the time you see a patch. So you have to have systems that can patch really fast because you have no time at all, right? And then you have all this regulation of how AI and other things are being included, right? And they would like you to be self-regulate, but if you don't self-regulate and you can't prove all this stuff, you can imagine where that conversation goes, right? So we have to get all the people who are part of this, because it's not just developers, it's not just testers, right? It's the DevOps guys, because infrastructure is involved, regulation and control and reporting and all those sort of things, and your AppSec guys. It's everybody involved in the software in your company has to be part of this conversation, right? So somehow we have to bring them all together and to fix this and not impact productivity too much. I mean, how hard can that be? Right? You remember this meme floating around? I haven't seen it very often, but it's, that relationship that we have. Oh, well, how can that be? Yeah. Okay. So what do we want to do? We need to have a lot more insight into the process. We need to stop paying lip service to vulnerabilities. We need to have better data. We need to be able to build systems that bring these things together. You have to have the best solutions. You can't have excuses. You can't say, we're really sorry that we shipped this car and the airbags didn't work. Our bad, we're really sorry. That doesn't work, right? That doesn't work in real life, and it's not going to work in software. So the data that you use to give you the insight is going to have to be better. You can't rely on Dependabot to tell you about vulnerabilities. You've got to start looking at other things, right? It's like you'll be looking at these different pieces. Given the scale of attack and the fact that vulnerabilities are coming out all the time and you've got to deal with them, you can't have hand-crank systems. And in fact, the regulations require, or will require, very little human involvement, from pressing the button that says, let's build it, to providing something that's shipped. No human beings involved. Because every time you have a place where a human being can be involved, the system will be compromised. So they focus very much on that automation and control. Right. Things like S-bombs aren't just a doc that you go, hey, it's not like your POM in your program. These are legal documents. And now you've got to deal with them in a different way. Somebody in your business will be going, where are we going to put this? because we have to prove what we shipped. So therefore, we have to keep this safe. We have to show it couldn't be tampered with. Right? It's a legal document. Right? So you've got to have systems of records for these sorts of things. Right? And you've got to bring all these different views together so that everybody understands why this is important and how they play in it. Right? And whatever you build, whatever you do with everybody who brings together, you've got this last thing. You've got to make sure that the management in your company or organization is behind this, because they're the ones with the neck on the line. If things go wrong and there's consequences from financial or criminal consequences, it's not going to be a developer. It's going to be somebody in the management team. It's going to be executives. And so you have to come up with something that you can get these guys to pay attention to, right? Which is pretty scary, right? So how are we going to work together? So I'm going to talk about something now that I found really valuable when I started when I took over this DevOps team. So I went into the DevOps team as a developer. I was the technical lead for the Java team at IBM. I sort of got a bit bored with that, wanted to do something else, and this offer came along. And so I came in as a developer with this idea of, why am I always being bothered with patch updates and stuff? What can we just get rid of all this crap that the DevOps team keep telling us to give? How do we get rid of this? I don't care. When I left it a few years later, I realized exactly why I should care as a developer. And that's one of the reasons I'm here and why I do other talks about security for developers, because the light bulb switched on, right? And so we're going to talk about through how one of the ways that I found it really worked, something that actually brought people together. And it's quite straightforward. It's just the way it works. So you have to start off with an understanding that when you talk to people about the problem that you have, much as they will understand the words that you say, they may not get the meaning. And the importance of something to you, and their view of importance on that, is often missed, right? Because they have no shared experience, okay? So let's give an example of this. It's almost like day one. So I've got this team. There are hundreds of DevOps guys in this. And I go talk to the development organizations that these people are providing services to, and I have a conversation. And I go, what's biting you? What can we fix? And the first one was this particular service, right? And it turned out that the DevOps team and the development team had a completely different view of how available this service was, right? And here's the conversation. So I go talk to my team and I go, we're being asked to make sure that this service, critical service, is available 24/7. And they go, it is available 24/7. The development teams go, no, it's not. We've been keeping track of this, and it's down on a regular basis. And so the IT guys go, yeah, well, our 24/7 doesn't include when we take it down for updates. I'm like, what? Yeah, no, if it's down for updates, it's not part of 24/7. Okay, WTF, right? And then we go, all right, but what about the other times it's not available? And this team said, well, if the reason this system down is somebody else's in the IT organization, like the SAN goes down, that's not our problem. So we don't record that as downtime, right? And it's like, what? So what came out of this conversation, and it was a bit longer than this, as you can imagine, was that even terms like 24/7 doesn't mean 24/7. It means somebody's going, oh, well, that's me telling you that it's as available as much as I can do. Yeah, 24, we strive to give you as availability as much as possible, but there are reasons when it's not available. And they didn't look at this from a point of view of that they had a contract. They were just going, well, it's available and it's not available, you know, and it's their view of this life was more about their side of it than the end user's impact on the end user. Okay, we have this big mismatch, right? How many here have got kids? Okay, right. So if you have kids, you will have, however old, at some point you will have them in a pushchair, right? And as a first-time parent, you've got kids in the pushchair, you meet some of this stuff. And for the first time, you realize the challenge that all the other parents before you have faced. It's right because as a non-parent, you may pass by people struggling, but you don't experience it. You don't see it from their point of view. And I'm sure you can think of all sorts of examples, right? So the challenge for us to bring everybody together is to say, how do you get people who are never going to have the experience that you have because that's not their job, to empathize with you? How do you get them on board, right? So the way that we did this was we looked at it and said, you may not really understand our problem, but if we can talk about a way of representing it, if we could write a contract that we both agreed meant something to each of us, and that we were willing to honor both of those sides, we might be able to make a difference, right? Now, you know, when you create a contract, if you look at legal contracts, nobody ever reads it second time. That's no good. So we wanted a contract that was much more in your face, much more accessible, okay? Something mutually created. And so we started creating dashboards, okay? Now, I don't mean dashboards like complicated reactors where you have no idea what's going in. You know, I always love it, and you get those movies and the submarine's sinking or somebody, and somebody goes, yeah, I'll just press buttons and things happen. The dashboards for, say, reactor have only one user. There's only one, this is all for one person, the person looking at this stuff. It's not a contract, right? Same with this one. This is the dashboard for one of the World War II code-breaking machines, right? It tells you stuff, but you have to be an expert to understand it. And there's only one user. The dashboard you want is much more like this. Go have a look at your car dashboard, whether it's physical or digital, and think about how it communicates with you. Because when you look at these dashboards, they're very careful. They're very clever. They're not to overwhelm you. What do they tell you? Just enough status. How fast are you going? That's important. What insight? Fuel and range. That's important. You know, warnings, like have you got seatbelt and things on? Those sorts of things. Important things for you to pay attention to, but nothing else, right? And clear emergency. You are told that this happens, there's a bad, it's bad. So car dashboards are designed to communicate with you, right? But if you think about it, it's a contract between the people who produce the car and you. They're trying to keep you safe and give you just enough information. They could overwhelm you. You know, you see some people buy cars, they go and buy extra information, oil pressures and stuff like that, and go, great. If you know what it means, great. But most of the time, it just becomes extra noise. So, what we discovered, because there is magic here, was that the act of this, right? When you're trying to get technical people together and you're trying to build a common view, a measurement, right? Because a dashboard is a dial or a number or whatever. We used way back, this was dashing. It's a Ruby thing, you know, because that was where we started. Really simple. Gives you a simple number, okay? It gives you just enough status, just enough insight. This is what we strove for, right? You went, availability. What does availability mean? Okay, what I'm striving to achieve is a dashboard that the IT department can see and that the development team can see, and that both agree that when that changes shape, color, whatever, it means things are going bad and something needs to happen. It means that the IT guys don't have to wait for somebody to raise a ticket because they've already got an indicator that things are going wrong. And the development team don't have to raise a ticket because they know that if that dashboard is changing, that the IT guys, shared contract, go, that needs to be fixed, right? Priorities have been agreed, and you've described how you measure what's good and what's bad, right? And believe me, the very act of having these conversations, not towards some document or SLA, but towards how would you display this, brings clarity on both sides, because it brings clarity from the development teams. They understand more about IT's challenges, and it also, the other way around, because IT don't understand what developers do, but they get to get a sense of it through this, this view, right? Right. And it becomes this contract that either side agree is the thing that we care about. Doesn't matter what it means, we just agree that that's what's going on. So you can imagine building dashboards to lay out your software supply chain, your build process and things like that, so that you get the performance you want. So if throughput going down, you have a chart for it, right? I'm sure you have lots of those things, but you get the idea that a common one brings you all together, right? And when we did this, we went from having 1 or 2 dashboards, because I just put dashboards everywhere, and we ended up with hundreds of dashboards. And in fact, development teams took dashboards and went, oh, we can do our own things and stuff like that. It's cool, you do whatever you want. But the core stuff was visible. So people wouldn't come in and go, what's on my issue list to go do? They'd go look at the dashboard. And the dashboard would say, we have a problem, we go fix it, okay? And now you have buy-in. Both teams desperately need that dashboard to be accurate. The data behind it needs to be accurate. They need to provide it because they're both on the hook, one way or the other, right? And we found that people would stop shouting at each other and stop being belligerent and going, oh, it's development being unreasonable. It was like, no, we have a common ground. And that made such a difference across the board in terms of getting stuff out. Because at the end of the day, I was doing this because we were providing services to development teams, and we went from fragmented services that each got in the way, each of them had a problem in getting away with development, to something much more streamlined, because we'd agreed it and sorted out how we measured it, right? So when you look at what I said at the beginning, bad things happening in your software, plus fears about AI in the business, which is leading to lots more legislation and control, equals more work for us, or downsides. Well, I can say, I feel it that at least if you start looking at those sort of contractual dashboard communications things, that we can actually achieve what we're looking for, which is closer ties between the teams, a much more automated system, because you can build it and measure it, right? And if you have one of those, it's going to reduce the chores for everybody. Right? And then out of that, you get improved security and productivity because you're focusing on it, which means your managers are happy, and hopefully no one goes to jail. Thank you. Are there any? Oh, we've got to do silo for questions, haven't we? Thank you. People ask me questions already. Okay. Right. Okay. So Elon Musk doesn't want to be buying me gift cards. If he phones you up and you have a Zoom call with him, record it, because you'll make more money out of sharing that than anything. Do you know? Yeah, it's Elon Musk. He could do anything, couldn't he? Yeah. What's the second one? If the government doesn't understand software, then how are they going to enforce it? I'm sorry? They are enforcing it. They're going to make you feel the pain. It's your problem to figure out how to work our way from the pain, right? Their enforcement is going to be You did something wrong. We figured out you did something wrong. You take the pain. So it's scary, right? How about this one? One of the things that they're saying is you cannot ship software with known vulnerabilities in. Nobody has described how you measure that. Nobody's described who measures it. So the really nasty thing here is that you could go, I'm going to use Dependabot because it's cheap and easy, and I'm going to ship my code and I'm going to have no vulnerabilities because Dependabot isn't very good at finding this stuff. And then somebody else has bought maybe product from my company, which is much more capable, and goes, hey, you've shipped something that has vulnerabilities in. Government goes, hey, go to jail. Right? So the thing about this is, especially in the EU, that rather than try and get into the weeds about the detail, the view is that we'll sort that out in court. The EU lawyers have a different view of how to make this happen, and their view is that most of the software that's important has commercial backing, and if it has commercial backing, they'll do the right thing, and the details will come out in court. Okay. How could a malicious LLM be detected on a dashboard? I have no idea. Right, so those poison models, where I said to you, there is no way of telling one apart from the other. What you could do, when I say no idea, okay, we're beginning to get, just like Sonotype does vulnerability scanning and tells you about vulnerabilities, we're all beginning to put our hands into the AI space. Right, so there are AI things, so there are things you can measure. So if you have an AI model, it will eventually have an ML bomb, which you can scan, and that will tell you things, how it was trained and where it was trained, stuff like that. So we will get better at spotting them because we're starting to apply the same logic that we did for software. And we're going to find the ones that have no provenance. We're going to find the ones that require that you install malware from Python malware and stuff like that. That we can do. But the deep ones, the ones that have been trained and released, unless you trust the person who provides it, right? So ChatGPT, massive LLM, train loads of data, right? You're never going to download it because it's a remote service, and you have to assume that it's been trained properly. If you download something, a pre-trained model, and you can't prove the provenance, in fact, you run the risk of getting one of these poison models. Right? So you really want to be very careful about downloading pre-trained models where you can't prove where it came from, and or you can't get the data that was trained against. Because as soon as you get neither of those, you don't know those things, you have a black LLM, black model LLM, and it can do anything. Because as I said, the difference between being malicious and not malicious is a complete point of view. And currently, the scientists, computer scientists are saying that they can't tell one from the other. Hey, and on that scary thought, thank you so much for listening. Thank you for staying all the way through to JCon. I think there's one round left. Normally I say I'm around for the rest of the conference, but you know, that's what, 50 minutes. But if you have any more questions, then just come on down. Cool, thank you.